Thank you. So again, very welcome to our Open Operations Meetup of the 22nd of April. Today I'm very happy to have Angel Kafasov and Bozhidar Ignatov from Daiteap here, who will introduce their approach of cloud interconnectivity. Please take over.
Okay, so I shared the slides. Can you see them? Hello, everybody. In this talk, we would like to present our approach for cloud interconnectivity within the SCS project. This work has been done in the part of work package 4 lot 3, which is a public tender, where me and my colleague Bozhidar are working on lot 3, which is concerned with cloud interconnect. So first, I would like to introduce ourselves. The company that we work for, Daiteap, has a strong background in cloud technology integration and networking. Daiteap is actively participating in the open source cloud community in Germany, and we are also members of Alaska. We have released open source technology for multi-cloud management platform, which can handle compute, network, storage orchestration for public and private clouds. And we are currently working with SCS on the topic of networking. My name is Angel Kafasov. My background is primarily in DevOps, software development, cloud, and networking. And I pass the ball to Bozhidar to introduce himself.
Hello, everyone. My name is Bozhidar Ignatov, and my activities are mainly related to networking and routing, cloud and container deployments, and DevOps. Thank you.
Okay, so why we are doing this? The goals of the project are to provide cloud interconnect capabilities to the SCS community. That would be the cloud operators and cloud users. In the spirit of SCS, we are leveraging highly open source software, and we try to implement this technology in a flexible manner, which also supports flexibility and is minimally invasive. That would mean that we try not to break existing features and architecture, but just to add features seamlessly on top of it. And we are also leveraging the trend in data center networks, which are moving to pure L3 underlay. A couple of words about what we are not doing. So we are not tackling topics like identity federation and also the particular type of VPN that is available. We focus on certain VPN parts like MPLS and BGP, but we try to be as much as possible agnostic to the type of connection that is available in the data center. So a little bit about layer 3 and layer 2 networks in the data center. With layer 2, we have some issues in terms of performance, like slow convergence time, larger failure, and broadcast domains. And the trend has been to move the boundary between layer 2 and 3 more towards the server and the host, and thus to reduce the size of the failure and broadcast domains to improve convergence. And this is happening by the usage of protocols like BGP, BFD, and ECMP. We are also, the key component of this solution is the ovn-bgp-agent, which has a requirement of layer 3 underlay. So this is something that we need to do. Short look into the current network architecture in OpenStack. So in blue, we showed the existing network components. The Neutron is the main software as a service component in OpenStack, and it supports a variety of SDN control planes. OVN, obvious, is just one type of control plane that is supported. And has, in addition to plugins, it has drivers for network devices. The OVN-bgp agent, this is in red. It extends this capability outside the cloud. And the networking BGP-VPN is the API that allows assigning tenant networks to VPN connections. So I pass now to Bozhidar.
Let me to continue. To interconnect OpenStack cloud, mainly we will talk about BGP VPNs and MPLS VPNs. They are building block for backbone network engineering in past. This technology develops mainly first in the backbone of the telcos for connecting different devices in the telcos network with provisioning of quality of service and needed quality for the services they connect. BGP MPLS VPNs are the foundation for operators' VPN services. They are with controllable functionality and quality of interconnection services. What are BGP MPLS VPNs? MPLS is used to isolate the traffic of different VPNs over the same wire, over the same IP connectivity, with encapsulating packets in MPLS and with labels of different MPLS VPNs. Next is the support of BGP, which routes to indicate where and how to send packets, and this enables different paths and dynamic routes to be used. So as Angel said, our solution is transparent in regard of kind of VPN connectivity, so different kind of connections can be used. Next slide, please. So here is the basic diagram to interconnect clouds on different data centers with BGP VPN. One virtual machine on one cloud connects to the virtual machine on the other cloud, and traffic goes through OVN overlay to the network gateway node, and then through the BGP VPN, then traffic goes to the gateway of the data center, and through BGP VPN to the other data center, then down to the network gateway node, and through the Genève tunnel to node where the VM lives. So OVN continues to connect the VMs within the cloud. This is east-west traffic, and BGP with Fabric to connect between clouds. This is north-south traffic. Next slide, please. So what are the components we are using and how it works? First component is BGP, for which I will talk in depth later. We are running BGP speaker on each node connected to the top of the rack or data center gateway, and it advertises directly connected routes. This is the purpose of BGP here. On OVN OVS, controllers on different racks networks are used. Also, loopback IP configuration for the BGP connections, and FRR, which is the solution for the BGP deployment, and ovn-bgp-agent deployment and configuration. ovn-bgp-agent itself, this part works on the network gateway nodes. It reads from OVN database and then uses FRR to advertise host routes to workloads. It configures local VTIP devices for the EVPN node and redirects traffic to from OVN overlay. For the API, we are using upstream networking-bgp-vpn project, which we are using to interact with different objects and networks to be exposed. Next slide, please. Talking about BGP, BGP is a dynamic routing protocol. It advertises routes and allows to exchange routing using a collection of IP routing prefixes under the control of a single administrative authority, which is autonomous system. It works inside the autonomous system and outside, which is external and internal BGP. It can be configured as BGP unnumbered. Announce the default route is used through back IP. And the very important feature here is virtual routing and forwarding support, which we will use and expose for L3 isolation and adding routing tables. FRR is our choice of BGP implementation. It is a Linux Foundation project. It is a protocol suite containing not just BGP, but also different routing protocols, OSPF, RIP, and others. But here we will use BGP functionality. It has a beautiful shell to communicate with the daemon V2ISH. And BGP implementation with FRR is used for advertising by triggering from the ovn-bgp-agent. What is done through this advertisement? VRF is created. Then FRR is configured to rig routes for a new VRF. Dummy device is added, which is associated with the VRF device. And through this dummy interface, the routes are announced. And also RP-NDP is enabled on OVS provider bridges. So to expose VMs and load balancer IPs, it is needed only action is to expose it as added from the BGP dummy device. Next slide, please. Here is a basic BGP configuration with which the FRR daemon starts. Here I just want to mention and to point that this phrases redistribute connected is used. So connected routes to be announced. Next slide, please. So here we will start to talk about ovn-bgp-agent. Indeed, it is a Python-based daemon running on OpenStack nodes. It reads from OVS southbound database events and trigger the action. It also uses FRR-BGP to announce relevant IPs, VMs, and load balancers, and kernel networking capabilities to redirect traffic to from OVN overlay. To work properly, it needs deployed BGP solution to advertise as directly connected routes. Nodes need to be connected to BGP peers, leaves or DC gateway, and RPNDP proxy has to be enabled. Next slide, please. Here I'll talk about the architecture diagram of the agent. There are no modifications to core OVN or Neutron. It uses different drivers and watchers depending on what actions has to be triggered. For the drivers, mainly two drivers that we are looking at was BGP and EVPN driver. BGP has some limitations. Just to mention it here, it has to be installed on every node. There is no API, and all VMs and all balancers are exposed. We will be with focus on EVPN driver, which is used to advertise tenant networks on VX1 ID. It is installed only on network gateway nodes where the CR-LRP port is deployed, and as API is used networking-bgp-vpn project to select networks to expose. It uses different watchers to look at the southbound database port binding table for events, and actions depends on the driver. Other drivers can be integrated also depending on actions, which will be looked and searched in port binding table events. So later we will focus on EVPN mode driver. Next slide, please. Talking about EVPN driver, as I said, it advertises tenant networks. We have an API to select networks to expose, and traffic needs to go through a network node where the ovn-bgp agent is installed with this gateway port. And it can interconnect OpenStack clusters inside or across data centers. Next slide, please. How EVPN driver works? As I said, it uses network BGP VPN as API, with which interacts the users and administrators. Then BGP VPN driver adds VNI and autonomous system, which is used to the OVN node-bound database, and automatically translates it into OVN southbound database, where agent detects this event through watcher and triggers the needed actions. And then the agent wires the network and configures BGP daemon FRR. Next slide, please. Looking inside the EVPN driver, how traffic node goes between nodes. ovn-bgp agent with EVPN driver, it creates VRF, bridge, VLAX, and dummy device, which will be used to expose the IPs of the of the VMs to be associated to this dummy device. That pair is connected to connect VRF and OVS provider bridge. It reconfigures FRR with VRF to the EVPN and out routes in the VRF routing table, so to redirect traffic to subnet CIDR to BRX, and then through this that pair going into the OVN overlay. For the return path, it is needed OVS flows to be added, so the traffic to be redirected back from the OVN to the VRF. And the other main activities and part is BGP advertisement, adding VM IPs to the dummy device. Next slide, please. Here we are showing the traffic flow to the tenant network. VM of the IP can be advertised in a node where the traffic could be injected into the OVN overlay. This is the OVN network gateway with the gateway port. And once the traffic reaches this node, it is redirected to the OVN overlay through the provider bridge BRX, and through the Genève tunnel, it goes to the node where the VM exists. Next slide, please. As an API, we are using networking-bgp-vpn. How it works to expose VM on a tenant network. First, the BGP VPN is created as resource, and it is associated to a tenant or a user. Then a user can associate it to the BGP VPN resource, either a router or a network. Administrator creates BGP VPN resource, and user creates this association with network router to BGP VPN. Next slide, please. Okay, now I'll transfer the word to Angel. Thank you.
Okay, so I would like to say a couple of words regarding our SCS-related activities, what we will do in this project. First of all, we will integrate the ovn-bgp-agent and the networking-bgp-vpn plugin into core Ansible, packaged as core images, and also in the OSISM as well. Therefore, exposing user-level configuration so that the users can configure this feature. We create documentation for SCS, and we are starting with OpenStack as first integration. However, it is possible in the future to integrate with other technologies like other cloud providers, Kubernetes, and so on. But we are at the moment just focusing on OpenStack. As a result, we will provide this functionality to the community and to the users, and we will support already widely available enterprise-level VPNs like BGP and MPLS. But then in the future, we can support user-defined VPNs like WireGuard or IPsec. Yeah, and we are doing this with purely open source technology. Yes, Ralph, user is tenant, exactly. As next, we are also doing some integration with Gaia X. So how this fits together is that Gaia-X provides a secure technology for exchanging data and services. And there are currently multiple data spaces and marketplaces built using this technology. So one of the things that in progress are marketplaces for purchasing and offering connectivity services between data centers. And since this fits very well into our use case, we want to standardize this process and make it available to Gaia-X marketplaces. Once such connections are purchased by users, the orchestration will be done on the cloud side, on SCS, for which we will develop the technology to do it. Yes, as I said, we support these kinds of VPNs going into IXP, but also other providers. And we are collaborating very much with the Telos project, which is a Gaia-X based marketplace. And that would be the first place where it is integrated. For the future, other kinds of VPNs, and we can also connect to other data spaces as well. And that was all. Thank you very much. And I would like to open the floor for questions.
Thank you. Thank you very much. Yeah, Clown. Clown, it's your time to question for your question.
It was applauded. I don't have a particular question for now.
Okay, then Kurt.
So Bozhidar, Angel, great presentation. Thanks for sharing. One of the things I would ultimately love to do as a user, as a customer, is that I have these two clouds where I have my networks, and I now want to connect them using this technology, BGP-EVPN, if that's the choice. And I would love to say, well, those are my two networks, and I want to connect them and do some API calls, and then some magic happens, and then these two networks can talk to each other via a secure tunnel. When I saw your presentation, there was some admin steps involved in making that work. Why is that the case, and can we get over that?
Yes, I can start with the answer, and Bozhidar can jump in if he wishes. So, of course, this whole process requires support on the infrastructure side. So it is not possible just for the user to configure, but as a prerequisite, we need, maybe I can show better on the diagram. So the infrastructure in the data centers needs like BGP running on the network devices and on the routers, as well as some external VPN connections in order for this to work. So this process needs to be pre-provisioned by the operator and made available to the user. So if I have compute resources on two compatible providers, which have enabled this connectivity between them, then it is possible for the user to configure it. So we are thinking about some extension to the Horizon interface where I can say, okay, this is my tenant network and this is the VPN that I want to associate it with. And then the same is done on the other side. But of course, this whole pre-provisioning on the infrastructure on the provider side needs to be done first. Yeah.
Could go on.
So if we ask providers, and we could theoretically do that and say, well, this is a standard SCS feature. You as an SCS compliant provider needs to enable this. Then actually it would become a self-service thing.
Exactly. Yes, that's the idea, to offer this as a self-service to the users. And one of the advantages is that we are using widely available protocols like BGP, EVPN, and so on. So very likely this thing already exists in the data center and just needs to be enabled on the provider side. So the provider, we may not mandate it as SCS, but we can offer it as an option, so that if the connectivity is available, then the operator might choose to enable it for the users to take advantage.
Thanks.
In the beginning, Angel, you mentioned that this is an approach, and maybe you asked the ground here to have ideas to improve or to change. So use the platform also for your questions if you want to.
Yeah. Of course, this is work in progress. This is just one approach how inter-cloud connectivity can be implemented, and it will be very valuable to get some feedback from people with experience in this area or operators as well who are looking into this kind of functionality.
Can I add something to the previous question? As in the presentation we mentioned, we want the solution to be VPN and connectivity agnostic. So it is usual to administrators to create such an object and that to provide access or to associate it to a tenant, network, or user who then can expose their resources and VMs. Just want this to add. Thank you.
So are there questions or additions, ideas to improve or to change or to make it even better? Yes, Maximilian.
Here. First of all, thank you for your presentation. I have a question regarding Caller Ansible. You mentioned that you want to integrate the ovn-bgp agent there. Has there been any work regarding that in the upstream, or is this something SCS specific?
Not yet in upstream, but
okay.
Of course that would be the correct approach.
I'm asking that because that is something that my company has already been working on. So there's an open change in the open dev Garrett. Maybe if that's interesting, you can have a look at it. It's fully functional. It's just not merged. So.
Okay, very nice. Maybe we can sync afterwards.
Mm-hmm.
There's also a link in the, Sven, maybe you can say something about
that.
Yeah, I just
exactly.
That's I'm already reviewing that. That seems to be a good point to collaborate on, I think.
So first of all, yes.
If you integrated the ovn-bgp agent or also the VPN plugin to Neutron.
We've integrated the BGP VPN service plugin into Neutron. there is a service driver that is being integrated. That's also not much. That's also something that is being worked on. The FRR daemon and the BGP VPN extension for Horizon is also part of that.
Yeah.
So that's all in there.
Well, I think we can collaborate then very nicely on this.